This video is for section 3-4, determining an equation of a line. In the previous section, do you recall the situation where we figured out an additional point on a line when given its slope and a point? We would start with the ordered pair we knew and add to the x-coordinate and add to the y-coordinate to find a new point. We can use the same technique to write an equation for a line. If x1 and y1 are a point on a line, then there's another point with coordinates x and y if and only if, when we find the difference of the y values and the difference of the x values, it turns out to be equal to our slope. We can take this equation and multiply this to cause it to move to the other side next to the m to create point-slope form. So point-slope form of an equation looks like this. Y minus y1 equals m times x minus x1. With point-slope form, we can create equations for lines if we know a point on the line and its slope. Let's try an example. Write an equation of a line with this slope, this is the value of m, and this ordered pair. The 0 is the x sub 1, and the negative 3 is the y sub 1. These are the x and y coordinates of a point on the line. Let's apply the point-slope formula. Y minus y1, which is negative 3, equals, now the m, which is 2, x minus, now the x sub 1, which is 0. This is an equation of our line. However, let's simplify this up a little bit nicer. This minus negative situation can be rewritten as an adding symbol. Over here we can distribute. 2 times x is 2x, and 2 times 0 is nothing. One more thing that could be done is we could subtract 3 from both sides. That gets the variable y alone, and we get 2x minus 3. This equation is a little more compact than our point-slope equation, and so this one is preferred. When using the point-slope formula to make an equation, it is typical to take the time to transform the equation into slope-intercept form, and that's what I had done right up above. Slope-intercept form has the format y equals mx plus b, where the variable m is the slope and the letter b is the y-intercept. So in our example, this line has a slope of 2 and it touches the y-axis at negative 3. The y-intercept is the y-coordinate of the point where a line intersects the y-axis. Let's try another example. Find an equation of the line passing through the points with these coordinates. Remember, to find an equation of a line, you need to know the slope. So let's find the value of m. This is x1, this is y1. This is x2, this is y2. The little 1's mean the first point on the line. The little 2's are referring to the second point on the line. Let's use our slope formula. y2 minus y1 divided by x2 minus x1. y2 is negative 3 minus y1 is 3. x2 is 2 minus x1 is negative 1. Now simplify. Negative 6 over 3, which reduces to negative 2. The slope of our line is negative 2. Now we can use the point-slope formula. Let me write that down one more time. This formula has a few places where we're going to substitute numbers for the m and for the x1 and the y1. For y1, what do you fill in? Look at the original ordered pairs. What's the value of y1? It's 3. For m, what do you fill in? What's the slope? It's negative 2. For x1, what do you fill in? It's negative 1. This equation is in point-slope form, but let's go farther and change that into slope-intercept form. First step, let's fix this subtract and negative sign, which are side by side. That can be written as a plus sign. Next step, the distributive property. On the right side of the equals, negative 2 times x is negative 2x, and negative 2 times positive 1 is negative 2. Final step, add 3. That gets the variable y alone. And over here we have negative 2x plus 1. Here is slope-intercept form for our equation. From this we can tell the slope is negative 2, and we can tell where it touches the y-axis at positive 1. Next, let's discuss parallel lines. Parallel lines are different lines that have the same slope. Here's an example problem. Verify by graphing that the following equations are for parallel lines. Both of the equations are in slope-intercept form. I know that because I see the letter y alone. After the equals, I see the x term, and after the x term, I see the y-intercept. It's the constant number. I notice that these have the same slopes. I'm expecting parallel lines. Let's graph these equations. Starting with the first equation, we'll do it in this reddish-brown ink. We know that the y-intercept, the b, is minus 2. It touches the y-axis at negative 2, so I'm putting a dot there. We know that its slope, the m, is 3. Thinking of that as a ratio, that's a rise of 3 over a run of 1. 3 over 1 is the same thing as a 3. From this dot, rise 3 units, count upwards 3 units, and run 1 unit to the right to find another dot. Then draw a line through these dots. Now let's graph the other equation. We'll use green ink. Its y-intercept value is positive 3. So on the y-axis, there's a dot at positive 3. Its slope is 3, which as a ratio, again, is 3 over 1. So from this green dot, rise 3 units, actually count the squares headed up, and then run 1 to the right. Here's another dot on the line. Draw through the dots. Notice that the red line is parallel to the green line. Let's try another example problem involving the idea of parallel lines. Find an equation of a line that is parallel to this line, and it intersects the x-axis at negative 6, 0. Let's think about what we know about parallel lines. They have the same slope. So let's find the slope of this line. This is in the form ax plus by equals c. Remember, we know a formula to find the value of m when we have an equation in that form. It's the opposite of a over b. So we have negative 5 over negative 3. Let's simplify this. Negative over negative is positive, 5/3. The equation that we're looking for will have a slope of 5/3 because it's parallel to this equation that has a slope of 5/3. The other thing we know about our equation is it goes through the point negative 6, 0. That's x1, that's y1. Let's use the point slope formula to get our equation. That formula is y minus y1 equals m times x minus x1. Let's make some substitutions. What goes in for y1? It's 0. What goes in for m? It's 5/3. What goes in for x1? It's negative 6. And instead of leaving the equation like this, let's work on this a little bit more. Y minus 0 is just y. Over here we have 5/3, and in the parentheses, x plus 6. One more step, let's distribute. 5/3 times x, and then 5/3 times 6. 5 times 6 is 30 thirds, and 30 thirds is the same as 10. This equation is for a line that is parallel to this one here. One last vocab word for the lesson. You notice that this ordered pair in the example we just worked gave us an x-coordinate for a y value of 0. That point is called the x-intercept. An x-intercept is the x-coordinate of the point in which a line intersects the x-axis. Any place on the x-axis will have a y-coordinate of 0. So notice when you're finding an x-intercept, it is the value of x when y is 0. On the other hand, if you're ever trying to find a y-intercept, it is the value of y when x is 0. Let's summarize the lesson. We reviewed how to create an equation of a line when we know a few things about the line. We have to know the slope and a point on the line. If we don't know those things, then we have to have enough information so we can find the slope.